Today I'm going to show you how to use Spss to run a simple regression. Before we go into the technical part, let's review the formula for regression. In a simple regression, the regression equation is the regression line where you can find the smallest distance between the estimated value of y and the actual y value, which is expressed by y hat equal a plus b times x, where b is the slope. It's calculated by xp divided by sum of square of x. And the y-intercept is calculated by a equal y bar minus b times x bar. And as you can see, the formula itself is not that difficult, and it's highly similar to the correlation formula we talked about in the previous chapter. So even if you don't have Spss, you can still use Excel to calculate the SP, which is summation parentheses x minus x bar times parentheses y minus y bar. And sum of square of x is summation parentheses x minus x bar squared. And x bar and y bar here is just the mean of your variable x and your variable y. We are ready to start doing analysis in Spss. The data set we use is a school report card data set. In the first column, it reported number of standard met and all possible number of standard for a school district in this particular data set is 25. So the highest number is 25, which means the school district has met every single one of the criterion. The second column here is a variable we call median household income. This number is reported in thousands of dollars, so $49.08 is actually $49,080. The median household income is usually, we use that as an independent variable, as a predictor to predict the quality of the school, and the quality of school here is expressed by the number of standard met on the school report card. So let's start the analysis. Click Analyze, and under Regression, there are a lot of options here. We're going to go with the simplest form of regression. You see a pop-up window asks you what is the dependent variable of this analysis. And as we just talked about, number of standard met is your dependent variable. So we move it to that box. And the next one is your independent variable, and we are going to use the median household income as the independent variable. And once you specify all that, you can go ahead, click OK. The purpose of this demonstration is to explain all the table generated here automatically by Spss. And to make making notes a little easier, I simply copy each of this table into a Word document. Okay, here is my Word document. The first table in your Spss output file is a table. It just say the method they use is enter. The method enter means the computer, the SPSS, just carry out the regression calculation using this independent variables specified by the user. That's the next table we're going to see is model summary table. Model summary table here reported R, and that is simply Pearson's correlation coefficient between the median household income and the number of standard met. So that's between your the correlation between your dependent variable and your independent variable. R squares provides the percentage of variance from the dependent variable explained by the independent variable. The adjusted R square is a modified R square only relevant to multiple regression, because when you add an additional predictor in the model, R square always goes up. But sooner or later, you're going to run into the risk of making your model too complicated to interpret or overfitting the model. The R square takes the cost of adding a new predictor and compare it to the benefit, and then reports the efficiency of the new model. So the adjusted R square does not always goes up when you increase the number of predictors in the model. The last number here, it's standard error of the estimate. Standard error of the estimate is calculated as y minus y hat square summation and divided by the degree of freedom. So it reflects the accuracy of the prediction. So the smaller the standard error of the estimate, the higher accuracy the prediction is. ANOVA summary table presented the ratio of the variance explained by the regression to the variance left unexplained. And in this particular case, the calculated F is 32.486, which means the variance is explained by the regression is 32.486 times the variance is left unexplained. And the p-value associated with this F is 0.000, which is very small. And based on our previous decision rule on calculated p-value, if your p-value is less than your alpha level, usually alpha level default at 0.05, we reject the HO. And if your calculated p-value is greater or equal to 0.05, we fail to reject the HO. So 0.000 is less than 0.05, so we reject the HO. So basically, when we are using the median household income, trying to predict the school report card for each school district, we actually have a highly significant outcome, which means the median household income is a good predictor. And the last table is the coefficient table. Coefficient is reported two different types of coefficient. The first part here is unstandardized coefficient, and the second part is standardized coefficient. So, main purpose of running a regression analysis, you need to know what is your regression equation. And according to the coefficient table right here, our white hat, the regression line is, the intercept is negative 3.619 plus the slope 0.608 times x. Continue on with this, the standardized coefficient beta. This number is also a regression equation, but it's only under when both your independent variable and dependent variable are presented in standardized z-score. And this 0.727 is actually the same as the Pearson's correlation. So let's go back to our model summary of Pearson's correlation 0.727. It's right here. And remember, the R-square is the percentage of variance overlap between the dependent variable and your independent variable, which is 0.528. 52.8% of the variance of y, your dependent variable, can be explained by your x, your independent variable. Okay, and here's another way to look at whether that is significant or not. We have unstandardized coefficient, and we also have another column called standard error of the coefficient. So this calculated T 5.700 is actually calculated by the unstandardized coefficient divided by standard error of the coefficient. So slope is 0.608 divided by the standard error of the coefficient 0.107, and that's you calculate into 5.682. And this T represented 5.700. The differences is in SPSS, they take a whole lot more number than just 3 places after the decimal. When they do the calculation, it's slightly different due to rounding. And this number, 0.5682, is just we only retained 3 places after the decimal. So this is a little rough. Okay, so I just explained every single number on SPSS when you run a simple regression. So right now you will be able to interpret the outcome of a simple regression conducted by SPSS.